In this video, we're going to consider how to use Ngspice to model dependent sources and circuits. We've already looked at modeling independent sources, but now let's look at a circuit like the one that's shown on the screen and figure out how we can actually do a simulation with Ngspice. So this circuit is one that's familiar to us. You can see that it's got an independent source, a dependent source. All the nodes are labeled, and we're going to just start by making a netlist. Let's go into an editor here to work on this. I'm going to resize it so we can see what we're doing at the same time. Okay, I'm going to call this example 1. So I'll put that in the first line of the netlist. Example 1, dependent source. Say the circuit has a dependent source. Okay, there we go. Now, let's go ahead and start laying out the netlist. Okay, so we have a voltage source, which we'll just call Vs, and we'll say that it can be found between node A and node 0, and it is 6 volts. Okay, and recall that the first node that's listed here has to be the one that corresponds to the positive terminal of the voltage source. That's the order that we put it in: positive terminal followed by negative terminal. Okay, then let's add in next the resistor, the 2 ohm resistor, which we'll call R1. And we'll say that's between nodes A and B, and it's 2 ohms. And I'm just going to use 2 and not put in the ohms, the label. I'm going to leave aside the dependent source for the moment. I'll just skip a line for where we're going to put it in. I'll put the other resistor in, and I'll say that's between C and 0. Okay, and that it is 6 ohms. All right, now we need to talk about how we're going to actually model this dependent source. Recall that each of these sources is different. We look at this one. This is a voltage source, and it is dependent upon a voltage elsewhere in the circuit. Right here, the voltage between the voltage that is across this 2 ohm resistor. So now let's look at the manual. Okay, there's a manual that is for Ngspice, and I'm going to open it up now. I have it here on Canvas. It's not really difficult to find. There's an external link, okay, to where we can find the Circuitix user manual. You can always Google it if Canvas is not available to you. And when we do this, it's an Ngspice user manual. The current version, as of the making of this video, is 38. It is updated pretty regularly. So here we are, version 38. Okay, it's from October of 2022. And if we look here, we can see that I'm just going to scroll through and get to the table of contents. And what we're interested in doing is finding the description of how to model dependent sources. Okay, so here we go down. Keep scrolling. Finally, we'll get down here. Voltage and current sources, dependent sources, linear dependent sources, and that's what we're talking about. We can just go to page 101. Okay, so as we know, there are 4 different kinds of linear dependent sources. There are current sources, voltage sources that can be dependent on either current or voltage elsewhere in the circuit. The one that we're interested in looking at is a voltage-controlled voltage source. So let's look for that one down here. Voltage-controlled voltage source. Okay, so the way that we would include that is we would start off with the letter E, which is not intuitive. That's why it's good to be able to look this up in a manual. So we use E, okay, and then the next thing we specify are the positive and negative terminals of the source. So let's just go ahead and do that right now, and then we'll go back and look at the rest of it. So looking at the circuit, the positive and negative terminals of this source, which I'm going to call E1, are B and C. Right? Okay, now the next thing we have to consider are what are called in here NC plus and NC minus. Those are the positive negative controlling nodes. So let's look back at the diagram. The positive controlling node is B. The negative controlling node is A. And that will properly orient V1 across that resistor. So we can go into the editor and put that in. Okay? Positive controlling node, negative controlling node. The last item in this line, the last thing we have to specify, is the coefficient, the multiplier. Okay, so you look here and you see that this voltage controlled voltage source is controlled by V1, but the V1 is multiplied by 3 to get the proper value. So that means we're just going to put 3 in. Whoops, gotta do this right. Okay, put the 3 in here. And that specifies E1. And now we've laid out the whole circuit. There are only 4 elements in this circuit. After that, we want to put in the rest of the netlist, the other language that we need to put in, where we actually ask it to do stuff. Okay, so we have control, and then OP, operating point, and then we say let. Think about what is it that we're trying to get here. The thing we'd like to solve for here is the current. Okay, we like to get I. Okay, so we want to get I. We can't just call it I. We have to call it I followed by something. Let's say S, because this current is the current that flows everywhere in the loop, including through the independent source. We'll just call it let IS. Okay, it's going to equal a current. Okay, we use the current function to get it, okay, and we have to specify a voltage source through which I flows in order to be able to get I, okay. It's always the current measured through a voltage source. Now, it needs to be that the current is entering into the positive terminal of this voltage source in order for this to work properly. So we have the voltage source over here, the 6-volt source. We could use that one, but the current is flowing into the negative terminal of that source. And so if we wanted to use V source here, okay, we could do that. We would have to multiply it by -1. Okay? So that's one possibility. We could do that. Okay, right? That would work. Okay. Now, that's one way to do it, but we know also that I is flowing into the actual positive terminal of the dependent source. So rather than having to get I the way, you just using the independent source, we can actually put the dependent source in here instead. It doesn't have to be an independent source, just it has to be a voltage source to be able to do this. So this is a way to capture the current. And then the next thing that we're going to want to do is print this value. We'll print it right to the screen, and that's all we need to do. Okay, and that's it for this netlist. I'm going to lengthen the file a little bit and just show it again. Okay, this is the whole thing. It's a pretty short list, pretty simple. We have the 4 elements. We have the control language. Okay, so now I'm going to save this. And this is called ex1.net. Okay, and let's go over to terminal window and try to run this. I'll make this terminal window a little bit bigger so you can see what's going on here. If I can make it a little bit bigger, that'd be good. Here we go. Okay. Ngspice. And then we're going to feed it ex1.net and see what happens. Okay. So we were able to get it to work, and the value that's returned for the current is 3 amps, and that's correct. Okay, if you work out the solution for this by hand, you're going to find that that's the case. This is actually an example from the textbook that can be found in figure 3.4 on page 61. And so you can verify that this is the correct answer by doing hand calculations. Okay, so that's an example of how to incorporate a dependent source that has a voltage dependency. Now let's look at another example. In this example, we have a circuit that has a dependent source in it. Okay, it has an independent source as well. It's a current source, and then it has a dependent source over here, a current source also, and it's dependent on a current elsewhere in the circuit, namely the current that flows through the 6 ohm resistor. So the dependent source here is a current-controlled current source. And so we'd like to set up the netlist for this one now. All right. We're going to call this one example 2. And we can actually start making this netlist. Example 2 contains current control current source. Okay, I'll just write it like that. All right, now let's talk about what the elements are going to be. The nodes are marked here as well, as was true for the previous circuit. All the elements are in parallel. So we have a current source that I'm going to call IS, and it is, when we specify a current source, we always have the tail of the direction of the flow of the current specified first, so that's going to be ground, okay, followed by A, and then the value is 4 amps. And then we have the 6 ohm source, 6 ohm resistor, so I'm going to call that one R1, and we'll say that it is between A and 0, okay, and it has a value of 6 ohms. And again, I'm not going to put in ohms, because if I put in ohms, which I don't have to do, it looks like 60. I get confused when I do this, so I just put 6, and then I know what it is. All right, we have the dependent source. I'm going to skip that one for now. And then we have the other resistor, R2, which also is between A and 0, and it's 2 ohms. All right, now we need to find out how to represent the current control current source. We go back to the manual, and what have we looked at so far? Voltage control voltage source, voltage control current source, current control current source. That's the one we want. So that's one is here. The letter that we have to use in the first place for this is an F, so we can call it F1. And then the general form is positive and negative nodes, as is true for current sources in general. So let's go back to this. Okay, that's the diagram. So we'll call it F1, and we specify it the same way with the tail, showing the direction of the current 0 first for ground, and then we have A after that. Okay, and then as far as the other elements in this line go, let's go back and look at it again. We now have to put in VName, or VName. It's the name of the voltage source through which the controlling current flows. Okay, so let's go back and look at this again. The controlling current is I1, and it flows through a resistor. It does not flow through a voltage source. We need it to flow through a voltage source, however. So the way we're going to get around this is by using a ghost voltage. So here is the circuit redrawn with a ghost voltage inserted. And so let's fix the netlist to make this all work. When I look back at the netlist here, okay, I'm going to have to add in, I'm going to have to change this resistor R1 so that it's shown to be between A and B. Okay, and then I'm going to need to add in the ghost voltage, which I'll call V0, and that's between B, that's where the positive terminal is, and ground. Okay, and it has a value of 0 volts. All right, so the name of the voltage source through which the controlling current flows is V0. And then the last thing we want to put in is the multiplier on the dependent source, and that is 2 right here. Okay, so this F1 describes the current-controlled current source. It's between ground and A. The controlling current, I1, flows through this ghost voltage source here, 0 volts, and the multiplier is 2. So now we're all set with that. And then we've laid out all the elements that are in this circuit. And now we need to put in the control language control, and then operating point, and then the thing that we would like to display, we'd like to find is V as marked in the diagram. So we can't just call it V, we have to call it something else. So let's call it Vx. Okay, we can call it whatever we like. What does it equal? It's the voltage between A and ground. So you recall that wherever we're trying to find a voltage between some node and ground, we just specify the node. Right? We don't put two voltages within the function. Okay, if it's between any two nodes where one of them is not ground, we have to specify both nodes. But here, since one of them is ground, then we just specify the non-ground one. And then the next thing we're going to do is to print Vx. We'll do NC, and then end the netlist. So save this out, and we should be able to do this fine. Ngspice, hold it, I'll just clear this, Ngspice ex2.net, and we find that Vx is equal to 12 volts. Again, this is correct. If we do the hand calculations, we find that that is the correct answer. And so with these two examples, we have covered the two different types of controlled sources in this enough, okay, that you will be able to also model the other kinds of controlled sources that we did not directly consider. A source that's controlled by a voltage and a source that's controlled by a current. And this should be fine. That along with the manual should be sufficient for you to be able to model any kind of linear dependent source that you encounter.